Okay, just about ready to get started. Give it a few more minutes for everyone to hop online. Can everyone hear me okay? Just like leave a comment in the little chat box if you can hear me. Oh, cool. Now you can see me as well. All right. So, everyone doing good? Everyone doing well on this Thursday? Getting excited for the weekend? I know I definitely am. My parents are coming up later today. We're all going to go out to dinner, which would be pretty nice. And then my wife and I are driving up to Connecticut, pretty close to where we used to live. We have friends, family friends out there that are getting married. So definitely stoked and excited for the weekend. It has been a super busy week, and I am exhausted. But I'm really happy to be online right now and talking about computer vision with everyone here. So let's start this off and open up these slides. So today, September 12th, 2019, PyImage Search office hours. So I wanted to give a quick update to office hours from last week and improvements we've made. You know, I appreciated everyone that was online during these office hours and gave us really, really good feedback on how we could improve it and make it valuable to everyone who's attending. And again, like I'll say this now and I'll say it at the end of office hours, but please give us your feedback on this, what you liked, what you disliked, what you thought could have been done better, you know, the things that sucked, things that were awesome. You know, we need to know all that, because if it's not a good use of your time, then it's not a good use of our time either. So these office hours are really for everyone in attendance. They're for everyone to learn from. So if you have any feedback along the way, please just give it to us. So one of the points of feedback that we got was provide a mix of beginner, intermediate, and advanced questions. So that's exactly what I'm going to be doing this time. I picked out about 7 or 8 questions that I'm going to go through, and then any extra time will be spent taking questions directly from the chat. And again, some of these questions will be very basic. Some of them will be much more advanced. I also decided that we'll do a mix of code and discussion. So some of the questions we'll be discussing are just, you know, me talking to you, working through a problem and discussing how I would actually solve it. Some of the other questions though, like I'll open up an editor, I'll show you some code, and you know, an hour isn't enough time to go into a ton of detail on a code, but I'll point out what you should be looking at and things to pay attention for when using a given piece of code in your own projects. The other big suggestion was to actually publish the questions ahead of time. And if you actually go to pyimagesearch.com and then to the office hours page, you'll see right here that I've decided to put all of the slides that we'll be discussing right there for you. So anytime you want to attend an office hour session, I'm going to try and put the slides up about 24 hours in advance. So that'll give you a good chance to review the questions and walk into the office hours having a good understanding of what we're going to cover, and then it also enables you to bring your own questions as well. Going back to the presentation, the Hobbyist Bundle, Raspberry Pi for computer vision, that is about to release next week. I am so unbelievably stoked and excited for that. Myself and the team have been working really, really hard on it, and we're super proud of what we put together. And I think you're really going to enjoy it. And in fact, these are this is my printout of the book. This is one volume. This is about 414 pages worth of content that I went through this past week and applied a bunch of edits to it, both from myself, my personal edits reading it, and then from the editor as well. So again, this behemoth volume 1, 414 pages, goes out next week. It'll be all the text, it'll be code and the data sets that accompany the text as well. I'm super proud of what we've created, myself and Dave and David and Abhishek and Sayak, and I think you're going to be incredibly impressed what we've managed to do with just a small, cheap piece of hardware. You know, it's absolutely incredible what you can do with a Raspberry Pi in terms of computer vision and deep learning. And again, that's only the first bundle. There's 2 more left to go. So I'm willing to bet that by the time we're finished this book completely, we'll probably be at like 1,000 pages, if I had to guess, in terms of content, which puts it right about where the deep learning for computer vision with Python book is. If this is the first time you've been to office hours, I do with this basically a charity. I kind of select not a random charity, but a charity that's important to me in some manner or important to the community. And for each question that I answer today, I donate $50 of my own personal funds to that charity. And this week's charity is the Beagle Rescue of Southern Maryland. If you don't know this about me, I love dogs, and specifically I love beagles. I've only had beagles growing up. And one of my friends actually went through this charity to adopt a dog for themselves, and they were so helpful and so good that I want to be able to give back to the Beagle Rescue of Southern Maryland. So for every question I answer, I'm going to donate some funds to them. So let's dive into our first question, which I actually received from Twitter. And it says, I'm making use of one of the exercises on computer vision. I am stuck at this error, and it says the following arguments are required, -- image. This person has searched for the solution, and do they have any videos or any tutorials that can be of help? So believe it or not, this is a pretty fairly common question that I've been asked on the PyImage Search blog. It is a basic one, and it's not even related to computer vision OpenCV at all. It's just a basic computer science concept, if you will. If you've ever used the command line before, like you know what a command line argument is, whether or not you realize it. So, for example, like I'm gonna list the contents of this directory with the ls command. Well, I can say ls-l, and that -l tells the ls command to show this more detailed listing of the directory structure. That -l right here, that is a command line argument. So I decided to write a tutorial on command line arguments back in 2018. I encourage anyone whoever runs into these usage errors to go read this tutorial on command line arguments and then go and practice it. If you're studying computer science in school, there is absolutely no reason for you not to know how to use command line arguments. And that kind of sounds like a really blanket statement, which I try not to make. But seriously, you cannot go through your computer science career without knowing how to use command line arguments. I know with Jupyter notebooks, it's so easy to spin up a notebook and code directly in there. And because of that, I have seen and educated students who don't know how to use command line arguments. So make sure you educate yourself properly on them. And as a quick example, I have a little bit of code I can share. I'm going to increase the size of this so everyone can see. Let's see. There we go. So I have the shape counter example. It's from the PyImage Search blog, from the argument parsing one. Let's say I wanted to execute it. And the name of the script is shape_counter. And I go to execute this, and you get this error saying the following command line arguments are required. And if you go back to the question, that's the exact same question this user was having. They were having a problem with command line arguments. Just saw a question. Are you working with Anaconda prompt? No, I don't use Anaconda for no real reason other than that I just prefer installing and working directly from the command line, compiling from source, and linking my libraries that way. There's nothing wrong with using Anaconda. You just have to understand your Python path properly. If you don't know what a Python path is, go read up on that. It's super helpful learning how to import libraries and deal with types of fancy stuff. And it's also a good way to shoot yourself in the foot by accident. So read up on command line arguments for sure, or excuse me, read up on the Python paths for sure. So going back to the question, we encounter this error and it's telling us that we're missing 2 command line arguments, the input and the output. Input is the input path to the image, and the output is, the output path to the image. So that requires us to actually pass in these arguments to the script, meaning I don't have to go in here and edit anything, right? I don't have to manually type in the paths to these files in the code. I can just do it from the command line argument. So if I say Python shape counter, I'm going to say, let's supply input 01.png, and this is what input 01.png looks like. It's just it's a set of shapes in an image that we're going to detect and count. And I want to supply an output path. And I'm going to say, let's name this output file officehours.png. So when I execute this script, the script is going to load the input 01.png file. It's going to process it, and then it's going to spit back out the officehours.png file. So let's execute this. Actually, it looks like I have a different error now. Wow. I wonder what this error is. This could be like a fun time trying to, or a fun live session of debugging why code errors happen. Huh. I didn't test this. This will be fun. Okay. So we ran into an error with cv2.drawContours, and it's telling us that perhaps no contours were found. And these OpenCV error messages can be like a total pain to debug, and that's fine. So I'm glad this error happened, because now I can show you how I actually go through and debug random OpenCV errors like this. Okay, so let's verify that our image was properly loaded, and let's check it. And the way I do that is I say print image.shape. And if the image is loaded, it'll show me the spatial dimensions of the image. And if it has not been properly loaded, typically because the path to the input image is incorrect, then it'll tell me that the image has no attribute.shape. So it's a good way to quickly debug whether or not there's an issue with the path to the input file. So I'm going to execute this. Sure enough, our image is 600 pixels by 561 with 3 channels. Great. So we know our image has been properly loaded at this point. Let's take this same code and take it down here. And what we're doing here is we're converting it to our input image to grayscale. We're blurring it, and then we're applying a threshold operation. So looking at the contour extraction code, we're making a copy of our threshold image. So that's the last variable that's being passed into the find contours call before this error occurs. So let's check the shape of it. And you know what? Let's also look at the image itself. So we're going to go back to our code, execute it. All right. So we know for a fact that this is working properly in the sense that the threshold image is popping up, but we're still running into this contour error. All right. So let's check out the size of this, or the length of this list. In between OpenCV versions, you started seeing differences in how the cv2.findContours tuple is actually returned. So in OpenCV 2.4, it would return a tuple, and in OpenCV 3, it returned a 3 tuple, and I think in OpenCV 4, it's now back to a 2 tuple. That's probably what the issue is, and actually looking at it, I can see the issue now. Let's check out the length of this contours list. Aha, so there's only 2 entries in this contours list, but our code is actually expecting 2, or is expecting three entries. So this is actually an old piece of code, and I was looking at this line right here, and I realized, oh man, I totally forgot to use the grab contours function. So if I call grab contours function, which makes the contours, basically what the grab contours function is doing is checking your OpenCV version and then making sure it pulls out the correct entry from that tuple. So if I do this, it should work. There we go. So the script executed without an error, and if I go back to my directory with all the code and the images, you'll see there's a new file named officehours.png. I open it up, and it tells you right here, found a total of 17 shapes in the input image, and then we've drawn a nice little contour around each of the 17 shapes. Now, let's say I wanted to change, instead of officehours.png, let's call it test.jpg. Run the script, and you pop back over here, and again, notice there is your test.jpg. So notice how I'm not editing any of the code. I mean, I had to edit the code, obviously, to resolve the error, but I'm not editing the file paths directly in the code. I'm doing this all from the command line argument. And that's what this reader was originally asking about. So I hope that helps address your question. And again, if you're ever stuck with these errors that like complain about how you need specific command line arguments, on the PyMageSearch blog, we call them usage errors. And the reason we call them usage errors is because at the top of every script that you download from the PyMageSearch blog, we have this comment up here that says usage, and all you have to do is just copy and paste these commands into your terminal to get the script to run. So if you're seeing these errors, it's because you're not following the proper usage. So if you ever see me tell you, hey, check your usage, or if you see either David or Dave or Abhishek or Sayak like email you in response to an error and say, hey, your problem is a usage error, go check your command line arguments. Now you know what to do. And also you know what to do when you encounter contours errors. I did not plan for that to happen. So I'm happy it did, because we all learned something along the way. So I have a question here I see in the Facebook chat. Is the website version of this tutorial available on PyMageSearch? Yes, so parts of it are. I would start here with the argparse and command line arguments one. And what's the other one? What's the other one that I would, I think it's called shape counting. See if that one's it. So I'm not seeing it right here. I'm probably blanking on the name of the tutorial. It might be shape color. I'm starting to blank on the name of it, so I might have to get back to you on that one. Determining object color. So this is some of the example images, and some of this code is inspired from this tutorial right here, determining object color with OpenCV. You can download the code and the example images from this tutorial, and then you can extend it and do whatever you want with it. So I saw another question asking about what IDE I use. I use two IDEs. For quick hacks and putting stuff together, I really like Sublime Text because it's just super fast and easy to use. For more advanced projects, I probably use PyCharm most of the time. I like PyCharm despite it being a full-fledged IDE. I did a lot of Java development growing up, especially right out of college. So I used a lot of Eclipse, and for a while I just hated those IDEs because they were just so bloated and they would consume so much CPU and so much RAM. And then, I didn't like it. But once I got out of Java for a year or two and started using Sublime Text a little bit more, I noticed there were features that I was missing that I liked. So because of that, I hopped back over to PyCharm. But again, PyCharm is probably really only useful for larger projects. I wouldn't use it for super simple scripts. But I will say, if you are on a Raspberry Pi, if you want to develop directly on the Raspberry Pi, use a lightweight editor like Sublime. If you use PyCharm, it'll be way too much bloat. And in fact, I doubt it would even really run that well on the PyCharm on the Raspberry Pi. A better solution would be to actually configure Sublime or PyCharm to actually automatically sync or SFTP your files directly to the device. That way, you're not wasting computational resources. And in fact, if you check out the Raspberry Pi category on the Pi Image Search blog, we posted a tutorial, about remote development on the Raspberry Pi, and these instructions apply to like any remote development. But we were very motivated by the Raspberry Pi, and this tutorial will teach you how to configure your configure Sublime or configure PyCharm or SSH or whatever you're using to perform remote development. So if you're interested in that, if you're interested in using Sublime on your desktop to actually write code on your desktop, but then have it execute on the Pi, definitely go check out this tutorial. So let's see what's next. What's the next question? So this question is from Okan. He says, I'm a PhD in business management in Turkey. I wonder whether I will do converting text from photo to Python. For example, feature selection of newspapers. I want to convert multiple photos to text. Can I do that with Python? So the way I interpreted this question was that they're interested in newspaper clippings, probably something similar to this, like a screen capture or a printout or a scan of a newspaper or something like that. And they want to be able to detect, each piece of text, each text block, and then OCR it as well. And the question is, can you do this with OpenCV and Python? Yes, you can actually. And there are two tutorials you want to read. The first one is called OpenCV and OCR, and I'll pull that one up just so you know what it looks like. This one is OpenCV OCR and text recognition with Tesseract, and the other one is what's called the East text detector. It's a deep learning model that can be used to actually detect the presence of text and images. So if you pop open this tutorial, this is the first tutorial in the series that we did, and teaches you how to localize text regions automatically using deep learning models. So meaning it's actually very, very accurate. And the second tutorial in the series actually tells you how to take the East text detector, use it to automatically localize the text, and then pass that into Tesseract version 4 to do the actual OCR. It's important that you use the version 4 of Tesseract, because that's the one that has the deep learning based LSTM in it. That's much, much more accurate than the previous versions of Tesseract. So make sure you read these two tutorials first before you go into the weeds too much. But with that said, let's open up the code to it real quick. So I'm just going to copy and paste this example command real quick. Let's say change directory. And let's, once again, command line argument, passing in the name of the image. Wait for the script to load. Right now, it's just loading the deep learning model into memory. And then here we go. So you can't see it over here, but it's localized the 1983 and printed it to the terminal. And I'll press any key on my keyboard to advance the execution of the script. And you'll see that it's localizing each of these text regions. It's showing you the correct OCR. There's going to be some typos or I won't say it's a typo because I guess the computer vision algorithm can't really make typos, but it's a misrepresentation of what the text actually is. So what you actually see in OCR engines when there's typos is they'll take the text and then run it through a typo engine and try and autocorrect it back, or someone manually reviews it. So here you go. These bounding boxes aren't sorted in any real order, which is why it's kind of randomly being displayed like this. But you could use contour sorting if you wanted to actually get it to output in one clean linear scrolling, like left to right and top to bottom. So you can do that. I'll leave that as an exercise to you, but that's the general gist of how this algorithm works. So I hope this helps you with your PhD research. And again, check out the OCR tutorials if you need more help with that. Our third question is from Newman. And Newman says, I am doing a project on hand gesture at hand gesture recognition at an undergraduate level. My question is about the Raspberry Pi 4, and will it be able to support my project using at most TensorFlow and Keras, and probably needs to recognize 40 to 45 gestures. Secondly, I was wondering, can a Raspberry Pi interface with a graphics card? Is that possible? So graphics cards on a Raspberry Pi with OpenCV is a gigantic can of worms. With the Raspberry Pi 3B+, there were beta drivers, and I think Dave could probably look this up faster than I can, and then you can post it in the group chat. I think it was based on the Video 4 graphics card on the Pi 3, but it never really made it out of beta support, and it didn't really fully support OpenCV 3 or 4. Now that the Raspberry Pi 4 is out, it has a more powerful GPU or graphics card on the Pi itself. It's a different model than what was on the Pi 3. It's much more powerful, but the downside is, again, we can't really access it. So if you're using a Raspberry Pi and expecting to actually access the graphics card and have it improve your deep learning model inference, like, I would definitely stop right there and remove that assumption from your head. That's realistically not going to work. If you want to improve inference on the Pi, you should look at Google Coral's USB accelerator. Super fast, easy to use. Movidius's Intel Neural Compute Stick, NCS. That's definitely another good option. Their new API is so much easier to use, and it integrates directly with OpenCV. So it only takes 1 or 2 lines of code to actually tell OpenCV to perform inference on the NCS. It's probably one of my favorite things about the NCS, and it makes it so easy to use. But that's the second part of the question, right? That's when Newman was asking about graphics card. The other question is, can you do hand gesture recognition on a Pi using deep learning, using nothing but the CPU? So no graphics card. So is there some tutorial for this on computer webcam, not for Raspberry Pi, for gesture recognition? Great question, and the answer is yes. So what I'm going to show you now is a demo of our hand gesture recognition running on the Raspberry Pi, running in real time, as you can see. So this is deep learning with TensorFlow and a Keras backend. The model was shallow because we did not require a super deep model for this. We were able to get away with a shallow model. And this demo will be covered inside Raspberry Pi for computer vision. I think we trained it initially with I think 5 or 6 hand gestures, but there's no reason why we couldn't include more and easily support that. So Newman, if you want to work with hand gesture recognition on the Raspberry Pi, yes, it's 100% possible. Just try and keep your model on the shallower side. If you take a larger model like VGG or ResNet or some of the later Inception versions, you're not going to be able to obtain real-time performance. But if you keep it on a shallow side with as few convolution filters and fully connected layers as possible, you could absolutely do it. So I hope that helps you out. Moving on to our fourth question. This is a popular question on the PyMage Search blog, and I'm really happy I get to ask it or get to answer it today during office hours. And that is how to increase face recognition rate in an image of classroom with 20 to 30 students, getting very bad efficiency with dlib, and only a portion of the faces are recognized while faces in the back are not recognized. So what do we do about that? What Parth is trying to do here is build a smart classroom application. So students walk into the classroom and they sit down, and there's a camera mounted somewhere that detects their presence and then automatically automatically logs that they were indeed present for the course. So this gets a little more challenging in a classroom setting, especially a classroom that's really long, like a bowling alley or a lecture hall that could be holding hundreds of students. So for like my face, like right here, close to the camera, going to be far easier to detect than like if I'm sitting all the way back here and in the back of the classroom, right? So you need to be able to compensate for that in some manner. So like, how do you detect my face if I'm sitting all the way back there? The first way would be to say, I'm going to increase the resolution of my input frames. So my frames are going to be larger in terms of width and height. That'll enable the faces at the back of the room to seem that much larger and make it that much more likely for your face detectors to actually detect them. Because face recognition is a two-stage process, right? There's step one, which is detecting the actual presence of the face. That's called face detection. Face detection has absolutely no idea. Face detection has no idea whose face it is. It's just telling you that there is a face. The second stage of face recognition takes the detected face and then runs a recognition algorithm on top of it and then spits out the actual identification. So the first stage is, we got to make our face detector as reliable and as accurate as possible because we want everyone in the classroom to be counted. Like, imagine you had gone to school and like you sat and went to every class all semester and the professor's like, yeah, I can't give you an A, I have to give you a B because you didn't show up to class every time. But you were, and it may just be that the face recognition application completely failed. So again, if you want to detect people at the back of the room, increase the size of the frame to your face detector. The problem with that is the more data there is, the slower your actual face detectors are going to run. And that's true whether you're using hard cascades, if you're using hog and linear SVM, if you're using any type of deep learning face detector. The larger the input image is, the more data there is, and therefore the slower the algorithm is going to run. Another approach you might want to consider, it does require more hardware, but it may be slightly easier, would be to mount a camera, a second camera, maybe halfway back through the classroom. So you have one camera at the front of the classroom monitoring everyone, and then maybe one halfway down the classroom. That way you can monitor the back half. That would be another solution. The problem with that is, again, it's more hardware, more points of failure that you have to be worried about. The one thing I did want to bring up though is there's a really neat fully convolutional head detector that I found online. I haven't actually used this yet, and I really want to because it looks pretty cool. I'll probably write a blog post about it when I do. But here you can see this face detector is actually being run. It looks like in a coffee shop, and it's detecting people's heads as they move in and out of the coffee shop. And it doesn't matter if the person's head is fully visible or not. So that's a pretty neat face detector that I would probably encourage readers to check out. So like, even if you're working with lower resolution input images, you might be able to get a better head count. So that's the first stage. First stage is face detection. The next stage is, let's take each of the ROIs of each face and then actually recognize them. There are a handful of algorithms that you can use on the PyResearch blog. If you go under topics and then face applications, you'll find all of my face related tutorials. There's a handful of face recognition ones. I would recommend everyone read OpenCV face recognition, and then face recognition with OpenCV, Python, and deep learning. This one, the face recognition with OpenCV, Python, and deep learning, was the first tutorial that I wrote on face recognition. It uses dlib and Adam Gecky's face _ recognition Python library. So you probably are already familiar with that library in some regard. This tutorial, it'll compute the 128 dimensional face embeddings for a given input image, and then pass that into essentially what's a glorified k-nearest neighbor classifier, which may or may not be that accurate. For certain real world use cases, it might not be accurate. In that case, you want to use this tutorial, OpenCV face recognition. This uses OpenCV's, oh wow, look at that. I am wearing the same shirt in this GIF as I am in the live video. That is too funny. Wow, I didn't plan that, but that's hysterical. Anyway, this uses OpenCV's face embedding model and then passes it into, I think it's a linear support vector machine, or it's either that or a logistic regression model, probably an SVM, and then actually does the classification. So this one is going to tend to be a little bit more robust and a little bit more accurate in practice. The best possible accuracy I've encountered using these models is to actually take the dlib and face recognition module and then take those embeddings and pass it through a linear SVM. That'll give you much better accuracy than trying to use k-nearest neighbor alone. And if you scroll down through the bottom of this tutorial, right before the summary, right here, drawbacks, limitations, and how to obtain higher face recognition accuracy. Seriously, read this section. This blog post, I think, has like over 300 comments, and I bet 50 or more % of them, the answers are found right here in this section. So all of this section here will tell you how to improve your face recognition model. If you need higher accuracy, or if you're looking for different approaches to improve your accuracy, read this section. Okay, moving on to our 5th question. And it says, I have a question. Is there any algorithm that can retrieve images as well as information and hyperlinks or URLs about information related to an input query image? So you input an image and it returns more similar images as well as information about the image. So basically what this reader wants to do is they want to build an image search engine. And last week I used the example of like building a shoe search engine. So if I want to type in Nike shoes and then go to images, like let's pretend that we have this data set right here of all these images, and we created a web crawler to go out and gather them. So just showing a user a similar shoe isn't enough, right? Because if you snap a photo of a shoe, you're expecting the image search engine to go and find all similar shoes, and not only show you similar shoes, but show you where you can buy them, right? It's an image search engine. Imagine you went to Google and you type in a set of keywords and it gave you your search results back, but there was no link that you could actually click. Like, it kind of defeats the purpose. So the same thing is true here. Like, having the images themselves is not enough. So the way I interpret this question is, how can you build a crawler that can scrape the web, gather these images, and then allow me to also store the URLs and any metadata associated with where it came from on the web. If you want to do that, I recommend, I don't know how to actually pronounce this. It's Scrapey or Scrapey. Anyway, doesn't really matter. But it's a nice little library for Python, and it teaches you how to create these web crawlers. These, I think, even in some cases, distributed web crawlers. It will go out, crawl the web, and give you back a set of images and the URLs they appeared on. You do have to code this yourself. Like, it's not going to work automatically for you. You need to take the time and implement the library properly. If you check out the PyImage search blog and just search for Scrapey right here in the search field, you'll see I have 2 tutorials here on how to actually scrape images from the web. So check those out if you're interested in learning not only how to build an image search engine, but also how to pull out metadata from the page it was grabbed on as well. Okay, question number 6 is on parsing annotations. I received this one from Twitter as well. It says, Adrian, is it possible to convert one higher resolution image to multiple crops and also convert their labels accordingly for smaller images? So I wasn't really sure what this question was asking, and I went back and I replied, can you elaborate more on convert their labels accordingly? And they replied back saying, if 1/3 of the image has a human, it should take that from the original text or XML file and create a separate label for that smaller image, a fraction of the larger image. So the way I thought of this question would be object detection. And if we go into this parsing annotations directory, I have a data set from Davis King, the creator of dlib, and it's a set of front and rear vehicles. And the end goal was to train an object detector to detect and localize each of the vehicles in this data set. Davis labeled the data set himself, and if you check on the training.xml file and open it up, you'll get this, this XML file here. And for each image in the data set, you have this, this tag right here, and it gives you the file path to the image, and it gives you the top, left, width, and height of the bounding box coordinates, respectively. So, for example, image one.jpg is this one right here, and then for each of these bounding box coordinates, that maps to a specific object in the image. So what I gathered from this question is that they want to be able to loop through an annotations file like this, and then extract each of these bounding box regions, and then save it to disk as a separate image file. And at the very end, maybe a little bit more than that, write these locations to an individual text file. Believe it or not, this really doesn't have anything to do with computer vision in the sense of the actual question, right? It has a lot more to do with understanding basic file I/O and how to parse these XML files. If you know how to parse an XML file, this project becomes super, super easy. And if you've never parsed an XML file before, I would definitely encourage you to check out the Beautiful Soup. Beautiful Soup library is pretty awesome. I've used it before in a ton of different projects. This will show you how to parse a basic HTML or XML file. Another one is I think it's libxml or just LXML. I think it's LXML. This is another really good one that you can play around with and use that for parsing these files. So once you've learned how to parse it, it becomes almost trivial to extract each of these values, and then you can use NumPy array slicing and actually save each individual object from the image to disk as a separate image. If you don't know how to use NumPy array slicing, you should go read Practical Python and OpenCV. That book will teach you the fundamentals of computer vision and image processing. Or you can go back to last week's post on, or last week's office hours on NumPy array slicing. I have 2 questions in there that I ask, or that I answer, and I'll teach you how to do exactly this. This question is from Emmanuel. And they say, I have a question about multiprocessing. I'm using a GPU for inference with YOLO version 3. Looking at the NVIDIA-SMI command during processing, I see that it only occupies 2 gigabytes of the 11 gigabytes I have on my GPU. I tried it with 6 threads, and the inference sometimes returns garbage. Is that normal? Am I doing it the wrong way? Is there a better way to accomplish this? I need to process videos as quickly as possible. And then as an aside, they said, I'm using PyTorch. Maybe it's the framework that's causing the issue. So let's start with the first question, right? And that's when Emmanuel is saying that it's only the model itself is only occupying 2 gigabytes of the 11 gigabytes they have available on their GPU. That 2 gigabytes is likely all that it takes for the model to occupy memory. I don't have access to their model. I don't have access to their code. So I'm just making an assumption here. So with libraries like TensorFlow, by default, TensorFlow occupies all the RAM on the GPU. I think that might change in TensorFlow 2.0, but in TensorFlow 1.x, it'll allocate all the memory, and it doesn't dynamically grow as needed. It just takes it all. So that's the first thing. That's the first thing you have to realize is that don't really worry about that. And as long as you see that your model is actually in memory, you're safe in that regard. The second part of the question is a little confusing because it sounds like they're using threads or processes to loop over all frames of the video file, potentially multiple video files at once, pass them into YOLO, get the object detection results back, and then do something with those results. The way I would approach this problem is actually through a traditional producer-consumer relationship. So you have one process that's solely responsible for looping over frames of a video file, and you want to batch those up and then send them over to your GPU for detection. Your GPU is going to take them, batch them up because batching is more efficient, and send the results back to you. One tutorial that I really like on the PyResearch blog regarding this is, I think it's called Deep Learning in Production. And I wrote an entire series about this, and it more so deals with how to build a REST API for your deep learning models, like wrap your deep learning model in a REST API so you can call it programmatically, and shows you how to do that with Flask and Apache. But the same techniques apply here. It's all about kind of creating this broker relationship, this producer-consumer relationship between your process that's reading your frames and your process that's actually taking those frames, putting them on the GPU, getting the results back, and then sending them back to the original process. So go read this tutorial. It's a good read, and it'll teach you all about this producer-consumer relationship and how you can develop it with deep learning models pretty quickly. Let's see. This one is on question 8 from Clark on object detection. What exactly is being returned in a detections object from OpenCV? I see that it's a NumPy array of some sort, but I'm trying to understand the elements within this array. So before we dive into that, I have this tutorial up here pulled up, object detection with deep learning and Python. If you check out this code, what you see it doing is performing object detection and then drawing the result on the actual image. So here we have a horse detected, and then we have a person detected. Let's take a look at this code because it's something really subtle and important going on here. And that's right here during your detections.forward call. I'll zoom in on this so you can see it. So what exactly, oh, that's too much. There we go. What exactly is going on here on line 42? This is where the network performs its forward pass on an input image and computes these object detection predictions. Now, keep in mind with object detection, you ultimately want 5 values back. You want the class label of what is actually in the image or a particular region of the image, and then you want 4 values. And that's typically your starting and ending XY coordinates of where the object is in the image. So for traditional image classification, you only get 1 value back, and that's the class label. For object detection, you're going to get at least 5 values back. So that's going to be your label and your bounding box coordinates. And if you have 2 objects detected, then you're going to get 2 sets of those 5 values. And if you detect 10 objects, you're going to get 10 sets of those 5 values. So going back here in this code, you can see that we're going to loop over the detections, and then we're going to extract the confidence, and then we're going to extract our bounding box coordinates. But what do these values actually mean? Like how did I know what values to pull off? Like, how do I know the confidence right here on line 48 is accessible by index value number 2? So I wanted to address that. I'm gonna pop back over here to my slideshow and go to the next slide. And this actually shows you what is going on. The 0th index, because again, Python is 0 indexed, is your batch ID. So the ID of the batch itself that goes into the model. You pretty much always ignore this value in your OpenCV object detections unless you have a very, very good reason to need the batch ID. I typically don't have to worry about that too much, so likely you won't have to either. The first value, or the first index value, is your class ID. That is an integer representing the class label of that object. So you would take that integer value and then go look that up in whatever your classes or labels dictionary or list is. That'll give you a text value of what is in that particular region of interest. The second index, that's your confidence, or more simply your probability. The probability that the object detected is of that class ID. And then values 3 through 6 are your starting and ending XY coordinates respectively. If you're using a cafe model, this is pretty much what you'll see for object detection in terms of return values. If you're using YOLO or a faster RCNN model, it might be a little bit different. If I check out, I have some bookmarks in here that might be helpful for readers. So if you check out the samples here on OpenCV's GitHub, there's an object detection Python script. And if you open this up and you scroll down to line 115, this one will show you basically what I showed you right here. This is the format of the 7 values that come out of the object detector. Here's one for the region-based model. So this will actually give you the center X and center Y coordinate of the bounding box, along with the width and height. And then using these 4 values, you can derive the starting upper left corner of the bounding box. If you're using a model that you don't fully understand the output dimension of, you can either go look at the model definition file for Cafe, that'll be your .prototext file. But I would also go email the authors of the paper or the GitHub repo that you're using. They may have some better insight as to what the output values actually are. And let's see, is this the last question I have here? Yeah, question number 9. This one is on threads and processes, and it's from Wally. And Wally says, in my code I've derived from your tutorials, I found that multiprocessing was inferior to threads on every case except for RTSP stream decoding. The interprocess communication appears to be a major burden. Not totally unexpected, as the camera threads or processes need to push frames to the AI module, meaning the NCS2 or Google's TPU. RTSP decoding processes worked better because of a trick I used to avoid Python interprocess communication. Used a localhost broker to pass images back and forth. Could you perhaps expound a bit on the Python pool object functions, maybe a topic for office hours? So definitely go back to the PyImageSearch blog and read our latest tutorial on multiprocessing with OpenCV and Python. That's where this question originally originated from. And it's about distributing load across your entire system bus, across all cores and all processors of your system. It's interesting to me that Wally said that he noticed that threads performed a little bit better. And I say it's interesting because the general rule is you use threads if you're bound by I/O, meaning I/O is your bottleneck. For example, if we're building a web scraper, one of the bottlenecks is just going to be waiting for the page to load and waiting for us to download that back to our machine. So for those cases, threads are a really, really good idea to use. Processes, on the other hand, you normally use when you're doing CPU intensive stuff. So I'll just say that's the general rule that you want to keep in mind. If you're using threads, use threads for I/O tasks, and if you're using processes, use processes for CPU heavy tasks. So let's see, what time is it? It's about 2:57. I'll take one question here. How can we do object detection with multiple cameras? Okay, so there are a few ways to do it. I'm making the assumption here that you have 2 or more cameras plugged into a single machine, and you want to perform object detection on each of the frames of each of the cameras. This actually goes back to my my producer-consumer relationship that I was telling you about earlier. Configure it as a producer-consumer relationship where you have one model in memory, or rather one model per GPU in memory, and then it does round-robin scheduling. So you pull a frame from video stream 1, and it gives it the video stream, and it gives it the GPU 1. You pull a frame from camera number 2, gives it the GPU number 2, and it keeps looping around in that way. So you end up sending batches of each individual GPU, and then you get those results back, and then you just have some additional logic that tells you what camera the particular frame came from. Yeah, that's pretty much exactly how I would approach that project. The only thing that you want to be a little wary of is if you have too many cameras on your machine, it's just going to overload the system and the system bus. It's going to be too slow. So there is a point of diminishing returns in which you just kind of have to say, you know what, time to get another machine and hook that up and hook up more cameras to that machine. again, there is a limitation to how many cameras that you can actually plug into a single system. It's not like you can get this 20-port USB hub and then like plug in all your cameras and expect it to work properly. It's not going to work like that. So we're right at 3 o'clock now. So I'm going to go ahead and close out this office hours session. I hope you all learned some stuff and had a good time here. And please, take a second once we get off this call, go to your email and send me an email to adrian@pyimagesearch.com and give us your feedback. Let me know what you liked, what you didn't like, what you thought could be better, what you thought was good, and we should continue to do. I said it before at the beginning of this call. If it's not valuable to you, then it's not something that I want to do. I don't want to waste your time. I don't want to waste my time either. So let's make this as valuable for each other as we possibly can. So please, take a second and send me an email and let me know what you think. And I will see you all here next week for another office hour session. See ya.